All right, let's look at the homework 16.4, problem number 9. All right, so let's evaluate this line integral. All right, so we have a line integral over the curve C. This is a closed curve, so I'll probably put the little circle here. All right, so f is going to have a component 2xy over quantity x squared plus y squared squared. And the y component is y squared minus x squared over same denominator. So x squared, y squared, and the whole thing squared. Right? And dr is going to be just dx comma dy. Right? So if you multiply this out, you're going to get this. So you have an integral over c. All right, so this is a dot product, so you're going to multiply 2xy over quantity x squared plus y squared squared dx plus y squared minus x squared over quantity x squared plus y squared squared dy. All right, so we can see that this portion right here is going to be our P, and this portion right here is going to be Q. All right, so let's use Green's theorem to rewrite this integral as a double integral. All right, so first we need to find partial of Q with respect to X. All right, let's find that. So we're going to use the quotient rule. All right, square the denominator. So we're going to have quantity x squared plus y squared and squared squared. So it's going to be to the fourth power. All right, derivative of the partial derivative of the top with respect to x would be negative 2x. Times denominator is x squared plus y squared squared. Minus the numerator is y squared minus x squared multiplied by derivative of the denominator, which is going to be 2 times x squared plus y squared, and subtract 1 from the power and multiply by the derivative, partial derivative of inside with respect to x, so which is going to be 2x. All right, so let's pull out the common factor. Looks like we have 2x, so I'm going to pull out the 2x here and the 2x together and put it in front here. All right. Then we have same denominator, so I'm just going to copy that. All right, what else is in common? You can see that, let's see, we have a quantity x squared plus y squared. There are 2 of those, so I'll just circle this so that we know that there's another one. So we have x squared plus y squared. All right, and anything else? Probably not, so I'm just going to write down what we have left over. All right, so it's going to be negative x squared and minus y squared. So we took care of this negative sign and x squared and the y squared from there. And then we have, let's see, negative 2 times y squared, so minus 2y squared. And then it's going to be positive 2x squared. All right, so that's that will take care of so negative 2y squared and positive 2x squared. All right, so one thing we can do is we can cancel x squared plus y squared. We have 4 of those, so we can turn that into 3 there. All right, then we can just clean up a little bit there. So this is going to be, all right, so you have a 2x And the combining, so I took care of 2x here, and the combining negative x squared and the positive 2x squared. So we have x squared. Then combining the negative y squared and the negative 2y squared. So that's going to be negative 3y squared. Alright, so you have a quantity x squared plus y squared to the third power. Right? So that's a partial derivative of q with respect to x. Alright, so let's find the partial derivative of p with respect to y. Alright, so what you're going to get is going to be, alright, so we just have to use the quotient rule again. So it's going to be x squared plus y squared and raise it to the fourth power, just like before. Right, now we have a partial of this guy with respect to y. So we have a 2x. Right, then the denominator, so you have x squared plus y squared minus, right, then we have 2xy, so 2xy multiplied by derivative of the denominator, which is going to be 2x squared plus y squared multiplied by partial inside with respect to y would be 2y. Alright, so we have that. Alright, so if you clean this up, you're going to get this. Alright, so you have the same denominator as before. Alright, so I'm going to, let's see, there's going to be a 2x here, and there's a 2x there. So I'm going to just pull that out, 2x. Right, and we have again x squared plus y squared. So you have two of those. So I take one. So we have we have x squared plus y squared. We got that. Then let's see. I think it's left over. So I'm going to just say, all right, we have x squared plus y squared left over from there. So took care of that. And then what else do we have? So we have negative 2 times 4y. So it's going to be negative 4y squared, sorry. Negative 4y squared because we have y there, right? So it's a negative 4y squared, right? Alright, so as before, we can cancel one of these guys, and this is going to be 3. Then what you get is going to be 2x times quantity x squared minus 3y squared over, right, quantity x squared plus y squared cubed. Alright, so you notice that we get exactly the same thing for partial of q with respect to x and a partial of p with respect to y. Right, so which means that once you use the Green's theorem, so by applying Green's theorem, right, it's going to be a double integral over the region D, whose boundary is this closed curve C. Alright, so you have q, so you're going to have q, a partial q with respect to x minus a partial p with respect to y, and then you have an area element, right? So we know that these two values are exactly the same, so you can see that this is going to be actually equal to 0. Which makes our lives a lot easier because the integrand is 0, so integral is going to be 0 as well. Alright, so let's type it in. Alright, answer we got is going to be 0. Alright, so let's check the answer, submit for testing. Alright, I came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.